Hello students, in this video we are going to discuss the problem comes under two-way classification in design of experiments. The problem is an experiment was designed to study the performance of four different detergents for cleaning fuel injectors. The following cleanliness readings were obtained with specially designed equipment for 12 tanks of gas distributed over three different models of engines. That is four different detergents versus three different engines. You have to take 12 different reading values. First row, detergent A versus three different engines. The reading values are 45, 43, 51. Detergent B versus three different engines. The reading values are 47, 46, 52. Detergent C versus three different engines. The reading values are 48, 50, 55. Detergent D versus three different engines. The reading values are 42, 37, 49. So in this problem, using the ANOVA, check whether there are differences in the results or in the engine readings. First, let us choose the hypothesis H naught, null hypothesis H naught. There is no significant difference between the column means as well as row means. That is, performance using detergents or performance using different engines. Let us take H1 alternative hypothesis. There is a significant difference between the column means or row means. That is, the above data are classified according to criteria. Two criteria. One is detergent and another one is engine. In order to simplify the calculations, first subtract each value by 50. So we get 45 minus 50 minus 5, 43 minus 50 minus 7. So in a similar manner, we have to find out all the values subtracting 50. So in this table, let us take the first column, detergent A, B, C, D, that is Y1, Y2, Y3, Y4. In first row, we get engine values, that is X1, X2, X3. So the different three engines denoted by X1, X2, X3, four different detergents denoted by Y1, Y2, Y3, Y4. From this given table, subtract each value by 50, we get minus 5, minus 7, 1, minus 3, minus 4, 2, minus 2, 0, 5, minus 8, minus 13, minus 1. Now let us take the total value, detergent as well as engines. We get sum of A, that is sum of I1 minus 11, sum of I2 minus 5, sum of I3 3, sum of I4 minus 24. Always taking the summation in engine values, that is summation x1 equal to minus 18, summation x2 equal to minus 24, summation x3 equal to 7. Next, let us take the square values, x1 square, x2 square, x3 square. We get minus 5 whole square 25, minus 7 whole square 49, 1 square 1. In a similar manner, to take the another square values and then take the summation, that is summation x1 square, summation x2 square, summation x3 square. So we get summation x1 square equal to 102, summation x2 square equal to 234, summation x3 square equal to 31. So these values are used in ANOVA table. First step, we have to find out number of observations. So here, four different detergents versus three different engines. The total number of reading values are 12. So let us take capital N equal to 12. Number of observations is 12. And then step number 2, take the total value T. So the total value T is from the observations minus 35. Next step 3, find out the correction factor T square by N. So we get 102.08. In step number 4, we have to find out total sum of squares from the observations. The formula is summation x1 square plus summation x2 square plus summation x3 square minus T square by N. Substituting the values from the table, we get 264.92. In step number 5, let us find out sum of squares between columns. That is sum of squares between reading values of engines. The formula is SSE equal to summation x1 square by n1 plus summation x2 square by n2 plus summation x3 square by summation x1 square by n1 plus summation x2 square by n1 plus summation x3 square by n1 minus correction factor d square by n. Here n1 is number of elements in each column. Okay, substituting the values from the table, finally we get the value 135.17. So in a similar manner, to find out the sum of squares between rows, the formula is summation y1 square by n2 plus summation y2 square by n2 plus summation y3 square by n2 plus summation y4 square by n2 minus correction factor t square by n. Substituting the values from the table, finally we get the value, SSR value 110.91. Now to find out the value for residual error value, that is sum of squares in sum of squares between errors between residual. So SSE equal to TSS minus SSC minus SSR. So substituting the values in this formula, finally we get 18.84. So using these values, now to form the ANOVA table, we need a source of variation, that is between columns, between rows, error, total, like that. Next one, sum of square values, next one, degrees of freedom, and then means sum of squares, and then variance ratio using F test formula, and then finally take the table value, corresponding table value. Okay, so substituting the values from the previous steps, sum of squares, that is SSC 135.17, SSR 110.91, SSE 18.84, total value, that is total sum of squares 264.92. In third column, degrees of freedom, between columns there are 3 columns, so degrees of freedom is 3 minus 1, that is 2. Between rows there are 4 columns, so r minus 1, the degrees of freedom is 3. In error, the degrees of freedom is c minus 1 into r minus 1. Formula is c minus 1 into r minus 1. The value is 6. Next, to find out the mean sum of square value between columns, between rows, and between errors. In between column, the formula is MSC equal to SSC by c minus 1. The value is 67.59. And in between rows, the mean sum of square value is MSR equal to SSR by r minus 1. We get the value 36.97. In a similar manner, to find out mean sum of squares between error is equal to SSC by degrees of freedom, that is r minus 1 into c minus 1, we get 3.14. Now to find out the variance value between rows and columns. First, to find out between columns, the ratio values, variance value is FC equal to MSC by MSE, because MSE is higher than the MSE value, so the higher value is take it as in numerator. So FC equal to 21.53. In a similar manner, to find out the FR value, the formula is MSR by MSE, because here also MSR is greater than the MSE value. Suppose MSE value is greater than the MSR value, we take the formula FR equal to MSE by MSR. So in variance formula, F test formula, the higher one is take the place in numerator. Okay, so FR equal to 11.77. So these are all variance value. Finally, it is the calculating value. So comparing with the tabulated value, so between columns, the tabulated value is 10.92 for the degrees of freedom, 2,6. So 2 takes from numerator, 6 from denominator. That is degrees of freedom between columns is 2, take degrees of freedom between error is 6. So tabulated value in between columns is 10.92. In a similar manner, in between rows is 9.78. So the calculated value comparing with the tabulated value at 5% level, both are higher. Both calculated values are higher one. Therefore, both statements of null hypothesis are rejected. Therefore, the alternative hypotheses are accepted one. Therefore, the final result is there is a significant difference between the both cases. That is, there is a significant difference between the column means and the row means. That is, the reading values are significantly differ in different result and in different engine. So let us discuss the another problem in another class. Thank you.